membership meeting. Lori, if you'll flip the page. We should have a very interesting meeting tonight as soon as I sit down. We'll do check-ins. I'll walk around and get everybody to sign in, and Lori has everybody's name and call sign on Zoom. Make a few opening comments, and then we're going to have an outstanding presentation from Ben. And those of you in the room have seen the device that he's going to be talking about. Those on Zoom will point a camera at it when he's explaining it, so you can also see it. And then, as we do in the end, if we have time, we'll do officers' reports, open discussion, and then checkout. That's where you get to deal with me again. So let me wander around the room, and we'll start out over here, as we always do, with D.
I'm D, KU4GC, Hillsborough.
Chris, KY4OU, Durham.
Ben, KO4BHX, Rougemont.
John, N4SUW, South Chapel Hill.
Dan, KR4UB, Southwest Orange County.
Bob, W4FK, Hillsborough.
And Paul, N0US, Hillsborough.
Sam, KJ4VWG, Durham.
Dave, NA4VY, Cedar Grove.
Pete, N4KW, Hurdle Mills.
John, KX4P, Pittsburgh.
Paul, N2XF, Botner.
Wilson, W4BOH, Suburban Hillsborough.
Boyd, KO4GJO, Hillsborough.
Mark, KR3AM, Chapel Hill.
Laurie, N1YXU, Chapel Hill. And on Zoom, I have Tim, KZ1TWR, Greg, KE8NNJ, Randy, KF40, Ken, KO4DHJ, Bill, N8BR, Ryan, N7RYN, JR, N4JQR, and Doug, KA5ETS. And if I missed anybody, you can send me a note in the chat.
And I'm Bruce, N1LN. And to start off on a good note, I think this may be the first meeting when I have badges for everybody in the room. So that's what it take, a little more than a year, but we've got badges for everybody that's here, and probably 100 more over there on the table for those of you that aren't. Okay, a couple opening comments. First of all, it's getting to that time of the year for the Christmas party. As everybody knows, it's the second Tuesday in December, which is, see, this is why you don't want me talking. It's the second Monday in December, December 11th. And the format is going to be much the same as it was last year, where people sign up. It will be the same price, $10 a head, as it was last year. Those that are coming bring a dish to pass, and the sign up is appetizer, main course, or dessert. And it is also at the same place as it was last year. Lori has already sent out an email to that point, giving everybody that information. We're going to be taking signups tonight and also signups at the November meeting, because we do need to have a good idea of how many people are coming before the December meeting, which is actually the Christmas party. And there's a sign up on the back paper. Quite a few of you have signed up tonight. If you want to pay, we're more than happy to take your money. Payment is in advance. So we want to make sure that when you do sign up, we know you're going to come, because we make sure the supplies are there to handle how many people have signed up. Okay, in the email, I have a flashcards over here. The PO box to mail your check to is in the email that Lori sent out. Dan, if they want to, can they use PayPal too? Okay, so you can also use PayPal, or if you're in the room tonight, we can use that old 4-letter word called cash. We have change since it's $10. We'll be glad to take a 20 for 2 of you, or we have 10s in the box that we can easily make change. So there you go. There's announcement number 1. Announcement number 2, last meeting, when we were here in September, we started talking briefly about the upcoming elections for officers and for board of directors at large. We will be spending more time on that in November. No, it's not going to be the whole meeting. I would fall asleep. But what I want to make sure that we do is to tell everybody what the officers and board members have been talking about and how we really hope to encourage more people to sign up for some of these offices. We want to get people that are interested in a specific office, perhaps, or interested or have a passion to try to do some more for their club. We have 108, 9, something like that, members. And we'd really like to draw from some of the 90+ members that, have not been involved, that have an awful lot of skills that we find out over the years. And we'd like to have you share those skills with us. One of the things we're going to try to do to make the transition easier, if you think you have an interest, is we're going to try to have like assistant positions or somebody that would work with the existing position. I'm going to use Dan for an example. Say you have an interest in being treasurer. Well, first of all, let's have a discussion to make sure you can, and I'm not going to diminish the office, but if you can't balance your checkbook, pick another office. Okay. But there are skills required to be the treasurer. And Dan would be more than happy to show you how he does it, what the requirements are, the processes associated month to month, quarter to quarter. And you really don't need to be intimidated by maybe the way Dan does it, because Dan does things in a significantly detailed way. I mean, he knows exactly what's going on at any point in time. Well, as long as we get the output from the job that's required, and that's what we'll talk about next month, you may choose to do it a totally different way. So it's the result that we want, not necessarily the process, but we want to show you the process that works so well now, so you can determine yourself whether you want to use it or lose it. And you get to work with Dan for a period of time, which could be a year. Okay, so we'll do that with some of the offices that really have a higher set of requirements to be able to take on that responsibility. So we'll spend more time talking about that in November, but we really hope that we'll get some folks that will come out and be interested in stepping forward and taking on a bigger role in the club, because we're fun. Most of us, present company not included all the time. Ask Lori. But really, it's a good place to volunteer your time. We do almost everything on Zoom if it's appropriate. So there's really, no extra time spent having to drive somewhere for a board of directors meeting. Walk over to your computer, log in. We have the meeting. We're always on time with a start and with the end once a month. So, and one more thing, since I'm talking about time, we will have estimates of how much time each position would take on a monthly basis, because I know everybody in this room has other things that they're involved in. And you're saying, well, I couldn't do that. I mean, that's going to take 15 hours a week or 10 hours this or 5. No, we're going to show you what we believe the basics of the job would take to get that done. So it's not over the top, all the extra detail kind of stuff, or it's not, maybe I can just get by. It's a reasonable estimate of how much time you could expect to take to do that role. So think about it. We'll talk about it much more in November. Okay, with that, let me introduce to you our speaker for the night. Ben Williams, KO4BHX. First time I met Ben, he came over to a Yagi party in our yard. Think about 2 field days back. We hosted a bunch of people and we put together, I think, 3 Yagis, maybe 4. We had a really good time, took a bunch of pictures, and those beams were used for a field day. Well, those of you in the room, if you look over to the left, look what I taught him. Everything in this is, come on, everybody laugh. Everybody, yeah. So obviously, this is not anything I taught Ben. This is stuff that Ben knows. He's about a light year ahead of me in technology and technical capabilities. But Ben is going to talk about a ham pie project specifically focused around satellite tracking and the antennas and the equipment to do that. With that, Ben, the floor is yours.
Great, thank you very much. Can everybody hear me all right? Right. So apologies to RKO for stealing their opening slide, but as you can see here, this is a very nice antenna tower that would give a fantastic footprint. And if you had a tower like this, I think it would be quite unnecessary to have satellites because you'd have a very simplified repeater that would get around a lot of the complications that are inherent in using satellites for amateur radio. Okay, so this is a project that I undertook as part of the HAM-PI group that's been meeting on a monthly basis for the last 3 years. Next slide, please. So this is a project that came from a group called SARCnet. That's an Australian group. It's the school's STEM outreach for science, technology, mathematics. And they've done a whole load of different projects for this outreach, including high-altitude balloons and things like that, and particularly satellite work. So this is an antenna rotator that points a Yagi antenna at a satellite, an amateur satellite. So it's a 2-axis rotator. It'll go around in azimuth and elevation, and it's computer controlled. So they have provided, so it's not a kit. In the bottom right-hand corner here, you can see they provide the plans for putting it together and some of the software that actually controls the motors. Yep. Next slide, please. So as we saw with that antenna tower, that would just have a fixed polarization and a fixed position. But with satellites, you can't just have them stationary unless they're in a geostationary orbit. Gravity will bring them back down again. So you need forward motion to make an orbital period. So orbital motion is a combination of the free fall of gravity and forward motion. But what that means is that the satellites can be moving very fast. And for an amateur satellite in low Earth orbit, that's about 17,500 miles an hour, 7.5 kilometers a second. So what that means is that it will zip across from horizon to horizon in about 10 minutes. Requiring a constant movement to keep a directional antenna centered on it. So what this does is it points the antenna at the satellite as it makes a pass overhead. So these two plots here are from a website called Heavens Above that you can identify a satellite and it will tell you when it's going to be coming over the top. You can see the ground track there going over the top, and on the left is a sky plot of how the satellite will pass overhead and a table of the information there. Next slide, please. So just to take a step back for a second and point out that in order to work satellites, you absolutely do not need a complicated antenna rotator. This was a project made for fun and to learn some things about electronics, but it can be done a lot more simply than that. I mean, just a simple rubber ducky antenna will actually hear the FM satellites, and you can just about work them with that. A quarter wave vertical is actually quite a good design for satellite work. And a lot of the basic schools projects actually use those because if you look at the radiation pattern in the middle there, it's donut shaped, it's maximum out towards the horizon where the satellite signal is going to be weakest, and the null is right above where the satellite's going to be overhead with maximum signal. So it kind of balances out fairly well. And the satellites actually spend relatively little time directly overhead and much more nearer the horizon. So that works fairly well. The two at the top right there, we have a double-cross dipole and a quadrifilar helix. And both of those are designed to give a fairly even pattern, which can accept polarization from all directions without really any nulls. Handheld works absolutely fine in the lower left. The only thing is it's a little bit of a workout. It requires basically holding an antenna at arm's length for about 10 minutes and knowing where to point it while doing all the other tasks involved. For the lower center there, that's a V dipole. For things like weather satellites, where they're on a polar orbit, where they always go north to south, south to north, you can just have that set up, pointing in one direction. The satellites will always come over in the same direction, and that can be very effective. If you do want a directional antenna, there's a couple of options here that is commercially available. There's the Yaesu G5500. that's regularly at the RAS Fest. So I think that's set up. You might have seen it there. And then on the right is a telescope, a Meade LX200. And it turns out that actually you can program in the orbital elements of satellites, and it will actually point the telescope at it, and you can mount an antenna on that. And somewhat ironically, the tripod that I'm using here actually comes from one of those telescopes, and I only found out about that functionality later. But anyway, that's another story. And you can actually see the solar panels on the space station through a telescope of that size. I've actually managed to see it, even though it's about 250 miles away. You can actually make out the silhouette and the solar arrays and get the silhouette of the space station, at least with that. Yep, so those are just some other options that are somewhat simpler in order to work with satellites. But this has certain advantages. It takes a lot of the sort of working out where the satellite is out of your hands. You can concentrate on just making the contact. Okay, next slide, please. So the construction protocol comes from SARCnet, as I've said. They provide a list of parts and an assembly plan. So the basic construction is centered around this 8-inch steel electrical box here that provides the chassis. It's about 1/8-inch thick steel, which is sturdy enough to hold all the bearings. And the major task here is just drilling all the different holes in it to allow the shafts to pass through. So those, and then the stainless steel hardware. So you can see bottom left there, pillow block and bearings. Yep, just there. So they need mounting into the side and the back plate there. 2 brackets had to be fabricated from L-shape aluminum angle, and they hold these 2 motors here, right angle DC gear shaft motors. And then between those and the shafts, using a timing belt system there, that's a toothed belt that can be tensioned by sliding the motor on the bracket backwards. And that allows a sort of slip-free rotation of the shaft. It's about a 3-to-1 gearing ratio on that. And then the antenna bracket up in the top right there is something I 3D printed, which is an item that would probably be quite hard to find commercially, but it can go from the shaft to the main boom of the antenna there. That's just held on with a hose clamp, but it's sort of part that you can just sketch up and 3D print in a day without having to try and source something that's very difficult to find. So that's the basic mechanical construction. It involves a certain amount of metalworking, but mostly just careful layout with calipers, center punching the holes, and then drilling on the drill press and getting everything fairly accurately lined up. But the original construction of this was made just, I think, by someone with a hand drill and an angle grinder, so it can be done without too much investment in equipment. I think a drill press certainly makes it a lot easier. Next slide, please. So the other part, of course, is the electrical side of things. So the main sort of computer on the rotator is an Arduino Pro Micro that contains a script in C++, and that controls these 2 H-bridge motor drivers. There's 1 driver for each of the axes, the azimuth and the elevation. So that's the 2 motors there below the antenna. And then the other major part of it is on the antenna there, and it's this little postage stamp sized sensor here that has an accelerometer, or 3 accelerometers in 3 axes, and a compass that also, or a magnetometer that works in 3 axes. So it's a tilt compensated compass, so it knows which way is north, and even when it's angled up, it still knows which way is north, even though the angle of it has changed. And then I'm just currently using a commercially available Arrow Yagi antenna for 70 centimeters and 2 meters. And then that is in turn connected to a computer. There's a laptop shown here, but I'm actually using a Raspberry Pi, partly because this is part of the Ham Pi group that was centered around Raspberry Pis to start with, but it's a nice platform for this sort of work, and there's plenty of computing power for what's required. So that's the basic electrical side of the construction. Next slide, please. So the H-bridge motor control. So this is not using stepper motors, but it's just using plain DC geared motors, only 2 RPMs. They travel very slowly. So the sensor is actually what knows the position it's at. That's constantly feeding data back to the computers. So there is no calibration of a home position or anything like that. It just knows which way is down, which way is north, and it knows where it's pointing relative to that, and it can keep track. So really, it's just a case of driving the motors clockwise, counterclockwise, speed control, or brake. So H bridges, as I'm sure you'll know, are basically 4 switches, MOSFETs, and by routing the current through one direction or the other, you can run the motors clockwise, counterclockwise. You can change the speed by using PWM, like a square wave of different duty cycle that will run them faster or slower. You can brake the motors by basically shorting together the 2 ends of the motor. So that's, and there's one driver for each of the axes just mounted on a single IC there. So that's the motor control. Next slide, please. And then this is the sensor that allows it to know which way it's pointed at any given point. So the sensor's on this arm and it moves the same as the antenna. So as the antenna moves up, the sensor moves up, and as it rotates around, it can measure the compass bearing. So it's 3 axes for both accelerometer and magnetometer. And as I said, it's a tilt compensated compass. So even as the antenna moves up to track a satellite, it can still measure which way is north. But the downside of this is it requires a 12-point calibration. So you've got, think of a cube with 6 sides, and you need to calibrate it for each 6 for both the gravity and the magnetism. So basically, you had to tape it to a wooden spoon and move it around each one of these points until it stopped beeping. And that takes a little bit of time. That was really the only difficult part of the setup that was involved in this. Next slide, please. So the magnetic North Pole is not the same as the geographic North Pole. It's moving fairly fast, but it's currently sort of up in the Arctic north of Canada. And from here, it's 9 degrees west. So it's a little bit to the west of due north. And then the magnetic dip, if you think of the sort of lines from the bar magnet, if you're on the equator, it will be pointing sort of level, but as we're closer to the North Pole, it's actually dipping down significantly, and it's about 60 degrees down from vertical. So we're 9 degrees west and 60 degrees down. So as you're calibrating this, you need to consider that you're calibrating to a cube on the level and a cube that's rotated and 60 degrees down from the magnetic side. And you can see those bar magnets pointing down. There's an illustration of that. Okay, next slide, please. So this was interesting. Not something I'd really thought much about before, but of course the radio window onto space. What frequencies do we actually use for communicating out of the atmosphere and into space? So this is a plot here with wavelength along the bottom and how opaque it is on the y-axis there. And as you can see, so moving from the left, so gamma rays and things like that are absorbed by the atmosphere, and that's a very good thing that we don't get baked or irradiated from that. Of course, we have visible light is able to pass through the atmosphere, and hence being able to see sunlight and stars and things like that. Once you get into infrared, again, it becomes opaque, and that's another very good thing because that's what stops everything getting very cold at night. And then we get into UHF and VHF, where again the atmosphere is transparent. So if you point your antenna out into space, those will escape quite nicely throughout into space. And then, of course, once you get to about 10 meters, and of course that's variable depending on the electron density in the ionosphere, you start to get refraction back down again, of course, for propagation. So we're looking mainly at UHF and VHF for satellite communication, partly because the atmosphere is transparent. The antenna size is quite convenient for both being on the satellite and for a rotator. And then I think towards the visible light, there's some wavelengths there that could become quite useful in the future. I've heard of talk of lasers and satellites being a thing of the future, but we'll have to see. But for the time being, certainly the 70 centimeter, 2 meter, and 10 meter is a good place for communication through the atmosphere. Next slide, please. So this is the antenna that's being used, a Yagi 70 centimeter and 2 meter. There's a diplexer installed in the handle. It can only handle 10 watts, but it allows you to both transmit and receive crossband simultaneously using a single bit of coax. So for a handheld or something that's full duplex crossband, you can transmit and receive using just a single radio with a single port on it. The impedance matching here is with a gamma match that has a number of advantages for this. It allows you to use unbalanced coax directly onto the antenna. The shorting bar there is what creates the 50 ohm match, and the capacitor there cancels out the inductance from these two being in parallel. And it also allows all parts of the antenna to be electrically connected, which means it's much simpler to construct everything really together on there. Next slide, please. This was an interesting thing. So apparently new requirements by the FCC are for all branches of amateur radio now to produce an RF exposure assessment. So I ran this through as quite a simple online calculator where you can just put in the basic parameters of what you've got. So the power of the antenna, the gain of the antenna in dBi, the distance of interest, so the distance from the center point of the antenna, and the frequency you're operating at. And just by putting in those 4 values, it will return these calculation results on the right, which will basically tell you if your distance of interest is a safe radiation exposure or not. And this, of course, is only 5 watts. So as you can see, in a controlled environment, which is where everybody around knows what's going on, basically, 2.3 feet. So as long as you don't basically have your head stuck right at the end of the antenna, you're fine. And for an uncontrolled environment, 5 feet. So as long as you have an exclusion zone of about 1 yard outside of here, I think everything's good there. Next slide, please. So there are 2 computers involved in this. One of them is the Raspberry Pi, and this is what runs the gpredict software, which is in the screen on the lower left there. So that's the software that can download the orbital elements for individual satellites, and from those compute the time and position that you need to be pointing the antenna to access the satellite. So the window in the center bottom left there is the elevation, the azimuth and elevation, and that will be constantly moving, and you can see the plot, the track it will take across the sky there. And then above, of course, because these satellites are traveling very fast, you get a Doppler shift. It's actually quite significant. It's more than a whole channel shift as the path goes. So it will tune both the uplink and downlink frequencies there constantly. And that would be quite a lot to take track of manually, I think, trying to tune those and point the antenna. So this takes control of all of those aspects. And then so it's controlling the radio via a CAT cable, and it sends the commands to the Arduino, which is on the rotator, using hamlib, which is a Linux package, using an EasyCom2 protocol. It's a standardized protocol. And then on the Arduino, which is on the back here, this is what's driving those H-bridge motor controllers and taking the information in from the sensor data. And it also has a thing called wind-up control, which is making sure that it doesn't keep going round and round and winding all the cables around and eventually pulling them out of the power supply, which does happen eventually. And it also takes control of that calibration process of the sensor that needs to be done before the sensor will work. And that's a screenshot of the Arduino code on the bottom right that's written in C++, which is a human readable code there, and a few parameters you can alter. Next slide, please. So the advantage of this particular setup is, as I say here, maritime mobile. Here's someone who's built one of these and actually had it on a ship. And I think because of this lack of home position, it could control the antenna and keep it pointing, even if you were on a ship and it was pitching or changing bearing, it would still compensate for that because it's literally just working off gravity and magnetic north. So there's no home position to lose, basically, which means you can move it around. It's portable. You could just set it up very quickly somewhere or move it to another place. Land mobile as well. Next slide, please. So one of the challenges, one of the disadvantages of this rotator, as I say, it's only 2 axis. So you've got the elevation and the azimuth. But one of the things you're lacking that you would have with a handheld antenna is that rotation of the polarization that would be your sort of wrist action. And as you can see on this SSTV capture at the top left there, these take about 2 minutes of scanning down for this one frame of a photograph to be taken. And as you can see, that green stripe there is where cross polarization has occurred. So you have about a 20 dB loss from the cross polarization, which is enough to cause these deep fades. A variety of things going on. So something I didn't know about before was this Faraday rotation, where electromagnetic radiation going along a magnetic field will actually rotate. And at UFH frequencies, that can be up to a whole rotation in the distance out to space. It's unpredictable because it's based in part upon the electron density as well as the atmosphere. So it's not something you can easily sort of calculate and correct for in that sense. And then the planet with the 2 radio towers on there demonstrates that these satellites have a large footprint, and what's vertical to someone in one location may very well not be vertical to someone who's situated quite some distance away. And the satellites themselves, of course, are very basic and have no stabilization. So all things considered, predicting polarization and controlling it's not a practical solution. So next slide, please. So the solution to this, and this is going to be one of the upgrades that I will work on next, is to come up with a circular polarized antenna. So there's a couple of different ways to go about this, but if you look in the lower right-hand side here, we've got a very similar Yagi to this, but it's actually 2 of them at 90 degrees, physically offset by a quarter wave and fed with this matching harness here, matching stub, which is a 50 ohm feeder with a 100 ohm T, and then 2 electrical quarter wave lengths of coax, which have to be 75 ohm to match the impedance between the 50 ohm antenna and the 100 ohm T match there. And by feeding the right-hand branch of the second dipole, you can do a left-hand circular polarized, and equally you can do a right-hand circular polarized. You could have that relay switch to do the 2 options there. And then the other option, if you want to make a shorter antenna, is not to do the physical quarter wave offset, but to have this phasing stub here, which is just another electrical quarter wave. But that's quite difficult to balance, I think, so the physical offset might be the better way to go with that. But I've got together the parts. I'm going to be 3D printing some pieces to put this together, to have a go at making a circularly polarized antenna that will then get around these fading nulls. Next slide, please. Types of radio for satellite work. So most of the satellites are cross-band repeaters. So the ideal situation is to have a full duplex radio where you can hear if you're actually making it into the satellites and hear your signal coming back. So there's the 9700 there. There's the Kenwood THD72. All of these can do that full duplex, but they're quite an expensive option. And I think the Kenwood's out of production at the minute. There's a Wouxun there in the middle that's a much more economical version, but I think it tends to get a little bit desensed and may not work quite as well in from 2 meters to 70 centimeters. It is possible to do half duplex. There's the ICOM 706, which is what I've got at the moment, that will work across the 2 bands, but you won't hear yourself coming back through the satellite. And ICOM 7100, just like that. And then another very good solution is just simply to have 2 radios, either 2 Baofengs or There's two Yaesu 817s there, so you can have one as a transmit, one as a receive, and that's a very good solution. It's one of the better ways to go about this. Next slide, please. So if you're not using the computer control of the radio, if you've just got a handheld you're using for this, rather than trying to sort of chase the Doppler shift of the satellite, you can actually channelize this. So the Doppler shift is fairly predictable. So you can program it to be sort of +10, +5 on the frequency, -5, -10 kilohertz, and that will then allow you just to shift the channel as the satellite passes and to get the center band. And we tried that out in field day, it worked pretty well. And using something like Chirp allows you to just set this up in a spreadsheet and then upload it to the radio. That saves a huge amount of programming in. And then the other thing you can do with here, most of the satellites have an access tone required, a CTSS tone, so you can put that in there as well. Next slide, please. So one of the things you need to keep track of is whether the satellites are actually active at the moment or not. They seem to get switched on and off very regularly, and quite a lot of them are just not active at any given point. So this is a website via the AMSAT webpage, which basically has hour blocks for each day, and people report whether or not they heard the satellite, whether it was active or not. So each of the satellites is a row on here, and you can see the black and white bar at the top are individual days there. And there's a number of satellites. So the blue is currently active, the red is not heard. There's the International Space Station on there. AO7 and AO91 are linear transponders. These Tevel satellites, the picture at the bottom left there, there's 8 of these CubeSats. These are only little 4-inch cubes. They were made by 8 different Israeli schools and launched on a SpaceX just recently. And they are absolutely brilliant. You can hear them really clearly. Just with a rubber duck HT, stood out in the garden and listened to people talking on those. And they all launched at the same time, so they're currently spread out like a freight train, about 2 minutes apart, and you get quite a long pass of those coming over. And then another fairly recent satellite launched about 2 years ago is this RS-44 that's in a special orbit that's very inclined and very elliptical. Which means that it goes up and spends a lot of time over the northern hemisphere and then dives quickly around the south hemisphere and comes back up again. So it's almost like a geostationary satellite, and it can, instead of that 10 minutes horizon to horizon, you get quite a good long time of that being up in the sky. And it's linear inverting, it's about plus or minus 30 kilohertz. So you can get a number of channels on that at the same time. So whilst most satellite contacts are very brief, that one's got a lot more bandwidth going on with it. The International Space Station as well has amateur radio equipment right now and acts as a repeater as well. Next slide, please. So a typical FM exchange is brief. It's not the place for rag chewing. Even calling CQ is apparently a serious breach of protocol because it's just an unnecessary extra part to it. So it's basically the same as an FM repeater. The only exchange really are call signs and Maidenhead grid squares. And it's just a very brief exchange. It's very fast paced. It's actually quite rapid to be listening to the exchanges as they go, but basically just call sign, grid square and state, and just confirming the QSL thanks to finish with. That's a basic exchange. Next slide, please. So satellites are incredibly busy, as we found out on field day. It's non-stop, horizon to horizon. Weekends are incredibly busy. So one option is to choose a pass, given that we're on the East Coast, out over the Atlantic, reduces the amount of competition. So here's one that's coming up on October the 17th, and it's nicely out offshore, so you're not competing with everybody west of us so much. So that's one good way to get a chance to get on the satellites. Arranging a contact with someone. They work in the same way as a repeater in that there's a capture effect, so only one person is getting through at any given time. And using a voice recorder for logging is a very good idea because there's a lot going on and not having to worry about writing things down is a definite advantage. Next slide, please. So there's a number of different modes. A lot of these satellites are just simple FM single channel repeaters. We've just got the access tone 5 kilohertz wide. It just standard FM, so you'd just be able to use an HT or something like that. A lot of the linear ones, though, you can use them just as a regular piece of bandwidth. So FT4 is one of the things that's run on here, and it's of course faster than FT8. It's only 7.5 seconds per cycle instead of the 15, so that's the preferred method there. CW is possible. You've got to work pretty hard to keep things, the Doppler corrected to keep a narrow filter on that. SSB, linear, inverting and non-inverting. So this is where computer control would really be useful, because trying to tune, of course, UHF, the Doppler is faster than VHF. So it would be a very complicated thing to balance both the transmit and receive there. But that software will take care of all that for you. So SSB again is on some of these satellites, that RS-44 that we had. And these are waterfall plots. The one in the center there, you can see the drifting off to the side, and that is actually the Doppler shift of the trace as the satellite's passing there. Next slide, please. So how do we know where the satellite is at any point? Well, 2-line elements is the basic answer to that. So why is it 2 lines? Well, because there are too many numbers fit on 1 line, and of course that's relating back to an IBM punch card. So it's a technology that's been around for some while, has not changed, but it works, and that's just fine. So here's an example of a 2-line element. So it contains the first bit of information here is just identifying the satellite. And this all relates to an epoch. So this is one observation at a single point in time. So there's a few bits along the top that are talking about drag and some information about, but the lower thing has the 6 elements that are required to describe an orbit and the satellite's position on that orbit. Thankfully, you don't actually need to know any of this, because in the bottom left-hand corner, this is the window in GPredict where you just say, upload the elements and click OK, and it takes care of all of that. But it's interesting to see what goes on behind the scenes with this. So all the information comes from NORAD. It's freely available via Celestrack to download, or if you just simply want to know where something is and get one of those plots across the sky, the Heavens Above website will give you a printout of what time and position satellite will be in. Next slide, please. So you have, for a satellite, basically 6 degrees of freedom. You've got position in 3 dimensions and velocity in 3 dimensions. So you need 6 pieces of information to describe what's going on. So the basic pieces of information, this was all worked out a very long time ago by Johannes Kepler there, who was working on planetary motion and came up with the rules for how orbits work. So basically you have orbit size, literally this the size of the orbit, the shape, whether it's circular or elliptical, the tilt relative to the equator, the twist, that's relative in space to Aries, the vernal equinox, the rotation in space, and the position of the satellite in the orbit. And from those 6 pieces of information, you know exactly what shape the orbit is and where the satellite is positioned on that orbit. Next slide, please. So these are the many different types of orbit you can get. So you can have, let me come in here and see. So we've got an equatorial orbit where the satellite can just travel around the equator, a polar orbit where it goes over each of the poles, and then an inclined orbit, which is sort of halfway in between the two. Circular or elliptical, and then by altitude, low Earth orbit, which is most of these amateur satellites, medium Earth orbit, and then of course a geostationary orbit is just far enough out that an orbit takes 24 hours, and therefore the satellite is positioned over the same point on Earth as the Earth rotates. Next slide, please. So how the software then goes about calculating the position of a satellite at a given point in time based on the information in those two line elements, you need to know the time epoch of that observation and the current time. You need the position in 3 dimensions, the velocity in 3 dimensions, and then using Kepler's laws that he derived, the 3 laws here. The first law being that all orbits are elliptical. An equal area is swept out in an equal time. So as you can see in the middle of the 3 laws there, as the satellite comes close to the Earth, it's going to sweep rapidly. And then as it comes out to the end of the ellipse, it will sweep more slowly, and that's to preserve the same area in a given time. And then the third law is just that the time it takes to make an orbit is proportional to the size of the orbit. So a larger orbit will take longer to complete. So with those 3 pieces of information, plus your position on the Earth, because of course the orbit is relative to the shared center of mass, which is essentially the center of the Earth, you need to compensate for where you are on the planet. There's this SGP4 algorithm that's a fairly non-trivial set of calculations that will work out, basically wind forward that observation to the current time. So it will take the satellite and wind it forward like clockwork, basically to the current time, and then know exactly where in terms of azimuth and elevation to point for that. And that accounts for position as well. Next slide, please. So as I said, the other thing that needs to be calculated, not just position, is this Doppler frequency shift. So at VHF, it's about plus or minus 3 kilohertz. So if you center on the channel, you're basically going from one side to the other. So there's almost no advantage to shifting if you just have a channel fixed, but about plus or minus 3 kilohertz. But at VHF, of course, that Doppler shift is proportional to the frequency that you're broadcasting at. So then it becomes more like 9 kilohertz. And there you really do need to be tuning, otherwise you're not going to hear as things are rapidly approaching or departing. So the plot on the lower left there is for the International Space Station. That's in a very low Earth orbit. And the blue trace there is if it was passing directly overhead. So that means it's coming directly towards you, passing overhead, and then going directly away. And as you can see, you've got the maximum upward shift, and then quite a rapid change as it moves overhead to a very low. If it's going around the horizon, of course, it's not approaching or departing as fast, so the Doppler shift is less pronounced. So you do need to take into account the elevation of the pass and how directly overhead it's going. And on the bottom right here, you can see this is a waterfall showing a transmission as the satellite passes overhead with a significant shift in frequency. So thankfully, that's all taken care of with the GPredict software. Next slide, please. So these are some of the things you can do, with just receive only, these SSTV pictures that can be downloaded from the space station. It's been absent for a little while, but there was just one occurred just the other day. They give out awards for that. You can get QSL cards for making contacts through the station. And there's a whole range of awards from AMSAT for making different numbers of contacts, for covering different grid squares, working all states, working all contacts, and even DXCC, which I imagine would be pretty hard to get, but something to aspire to maybe there. Next slide, please. Oh, there we go.
Okay, we're going to try to get the camera over here. Oh, okay, it's there. Okay,
Cool.
so the camera is now pointed at your, there you go.
Great, okay. Yep, so you want to see the actual construction. So these are the two H bridges here, 3D printed holders. All of this can be moved inside to weatherproof the box. There's a piezo buzzer here, which allows a beep when a satellite position is acquired or for the calibration. This is the Arduino single board computer here. that controls the H-bridge drivers and the information from the sensor. The sensor's on the end of the arm here, and that, of course, moves both round and up with the antenna, so it knows which way it's pointed at any given time. This is a Raspberry Pi on here that can be accessed via remote desktops. This will be a complete standalone, and you can access that remotely. And that is what runs the gpredict for the calculating the satellite positions. And there's an RTL SDR dongle on here, so that can be used as a receiver on a separate antenna. So you can have an RX TX arrangement for this. And then I'll just see if I can turn this around. So you can just see in here, these are the two DC motors, elevation and azimuth, on their brackets, adjustable for belt tension, because of course any slack in the belt will result in precision. The Yagi itself has a 3 dB beam width of about 30 degrees, and this has a pointing accuracy of about 5 degrees, so it's plenty accurate enough. It doesn't need to be pinpoint precise. These are toothed belts, timing belts on here, and the pillow blocks and bearings in there. And then this all does up in a weatherproof enclosure. Yep. There we go.
Excellent. Any questions? I've got a couple, but let me wander around with the microphone. Anybody? Let me walk to the back. Bob's got a question.
Probably one of yours. What's your farthest contact?
So far, Colorado, with an APRS signal. I've heard you can go all the way to the West Coast or across Europe just about. So it seems that 5 watts is plenty enough when there's a lot of obstructions in the way. And the space station is about 250 miles, and yet you can get a signal in and out of there just fine. I think you start to get very low in elevation when you go far, which has more absorption, but certainly in the order of thousands of miles, I think it's quite possible.
That was kind of my question, but when you had the awards up, you said Worked All Continents and DXCC, and I would say they're both a level of difficult reaching impossible.
I would have thought so, yes. I mean, I think they will give you the award if you can do it. I think it's probably but yes, I agree.
Okay, Jack.
Yeah, really interesting presentation.
Thank you.
I don't want you to flip back to it, but about the 10th or 15th slide was the frequency spectrum. Gamma rays, X-rays, radio waves. If you could talk about that for a minute, about what windows there are in the frequency spectrum that radio telescopes can actually be beneficial at, would be helpful, and why there are these absorption bands or areas of the spectrum that are not useful.
Right. Well, my understanding is, of course, HF, as we all know, gets refracted by the ionosphere back down. So anything at those wavelengths is just simply not going to escape into space. At UHF and VHF, of course, you don't have that reflection or refraction, so they just simply escape into space. Once you get up into the infrared, I think it's that the wavelength of the radiation is probably resonant with the molecules of water and carbon dioxide in the atmosphere, so they're actually being absorbed by the molecules. And then as you progress up, you're getting into daylight, which of course we're transparent to. And then we're getting up into the gamma rays and things like that. And I think that's probably absorbment on maybe the molecular or the atomic level, possibly. I'm not sure exactly what's going on with those. But I know that to observe in the infrared, this is what the James Webb Telescope is doing, is it's actually out in space, so it's not having to contend with the atmosphere. It's got a clear view then being above it. So Hubble, for example, I think it's only got a 16-inch mirror, but the advantages of being in space make it equivalent to a much larger terrestrial telescope, not having to contend.
Lori, any questions on Zoom? Yeah, if anybody on Zoom has a question, please put it in the chat. I've got a question that's going to take you back probably 28 years, probably before you were doing satellite. So we used to live in Leominster, Massachusetts. And at that time, we used LEO satellites.
Mhm.
I think it was RS-12 and RS-13, so that dates it right there.
Right.
But they were 10 meter and 15 meter.
Yes.
And I think in the radio club we belonged to, I made the first contact, which was somewhere, in central US.
Mhm.
But my second contact that got the whole club wrapped into this was actually in England.
Oh, wonderful.
And there, we were very sophisticated in how we handled Doppler. So those of us with a radio that had, dual receivers, I had an FT1000 MP at the time, also a lot of a boat anchor right now, but two knobs, following the satellite
Mhm.
on transmit receive, turning the VFOs to stay with it. And it was fun, but that's the only satellite work I've ever done.
Right.
So hardly as sophisticated, but very possible.
Absolutely, yes, but it requires a lot of sort of attention to how many different things you're juggling at the same time, I guess.
It is, but you could hear them both. You had to do it with headset, so
Right.
one radio in one ear, one in the other ear. But it was in my antenna at the time, we were in an antenna restricted neighborhood,
Mhm.
and I had a dipole about 40 feet off the ground, multi-band dipole. That was it. So
Right.
the old RS-12 and RS-13s were fun to work and easy to work.
Fantastic.
And I've never done this, but I know it's well, looking at the technology, it's come a long way.
I think so, yeah. I mean, you can, so it was just a fixed position antenna then without
Yeah,
rotating.
absolutely
Yes, yeah.
fixed dipole,
Yep.
30, 40 feet off the ground.
That's
Any
great.
other questions in the room? Good.
I was going to ask you how your polarization concerns would reflect a flat Earth model.
Right. Let me think about that.
I'm just
I'm
kidding.
not sure.
So I have a handheld log periodic made by Elk.
Right, yep.
I haven't used it. I've used it to talk to a couple of repeaters, but I haven't done anything with satellite work. My concern, I guess, and my hesitation is how, yours is so pinpoint precise. It's using data to track this. How accurate are the handheld versions to like literally talk to a satellite? I mean, are you looking at your phone and you're talking on your radio and trying to track this thing across the sky and your polarization is wrong?
It's not that difficult, actually. So if you go on the Heavens Above website, it'll give you a very nice plot that will show you basically the cardinal point at which the satellite's going to rise and set, and you'll have a sort of trace. It's quite easy at night because you've got the stars to go by or the position of the sun during the daytime. So you can get a pretty good idea of where in the sky it's going to be. And you don't need to be that precise. As I said, the beam width on these is about 60 degrees. So as long as you're sort of in the right ballpark here, you're good. They do make an Alaskan antenna that's got another element on that's 4, and that's narrower. But you'll be absolutely fine. I actually had this set up for a while, just pointed vertically, doing just a telemetry only receive that automatically uploaded to a data warehouse. So it was literally just pointing vertically, and it would get a huge amount of data, even just not aiming it at all. So, I mean, it's nice to be able to point, and it's a thing of beauty to watch it sort of track across the sky. But in terms of requirements, it's quite a forgiving system where it's not like pointing a telescope where you're either going to see it or not. You'll be all right with that.
I think we've got one second. I think I'll be right back.
Randy, I'm just going to ask you to unmute and make your comment that you put into chat.
Yes, I was just saying, hey, get my mic here. I was just saying I've done that easily with the handheld and just pointing the antenna with the ISS several times. It's really not difficult at all.
Yeah, another great tip, I think, would be at certain times you get the satellite hour, they call it, when we're in darkness, but the satellite's still in sunlight. And for the ISS in particular, you can actually see it. It's reflective enough that it's going to be the brightest thing in the sky. And that, of course, is a very easy thing to point at because you've actually got a visual reference. So that could be a good way to, to be able to point easily out to the antenna. And then you just literally just for polarization, just rotating your wrist and seeing where the signal's strong.
Any suggestions for field day? I mean, I think everybody and their brother and sister and relatives are all trying to hit the satellites at the same time.
Yes, yeah.
You can't overpower it because then you'll desense the whole thing. And any suggestions on how we could actually get in there?
Yeah, well, given that we're on the East Coast, we do have that advantage of the Atlantic. So I think picking passes where things are sort of far off to the east is going to maximize the opportunity there. Going for the sort of antisocial hours as well probably helps. As you say, using more than 5 watts is just robbing away from anybody else on the linear. Or with the FM satellites, you've got the capture effect. There's only one person speaking through. I mean, I guess practice is the other thing probably, and just getting the technique good beforehand. We very almost made a full contact. We did get a call sign repeated back to us on field day, but didn't manage to complete a full exchange.
Excellent, excellent. Any other? Yes, another question. Here you go, Dan.
Just to comment on trying to make a field day contact during field day. As you've mentioned, you can simply just point the antenna. We did have basically a compass and an inclinometer, so we knew where to start.
Yeah.
But once you hear it, you can track it. The real problem we had is during field day, a lot of stations are overpowering the satellite to the point you actually hear the signals distorting. So that's the real problem of getting in.
Absolutely. I think some of the satellites actually have a protection. We did hear one go off air, and we suspected that it may be that someone was blasting it with too much, and it actually decided to switch itself off during the pass. Yeah.
John.
Maybe one other question. If you'd comment about the different modes, I know some of them are on FM, some of them are sideband, or any of them on digital. And it seemed like there was another kind of a question. I think you commented about the power limit of probably 5 watts or something like that. I have tried doing satellite stuff with a homebrew antenna that had 5 elements for 440 and 3 elements, I think, for 3 elements for 2 meters. And I could hear the satellites. And I actually made one contact, but it was very difficult because I was using a little handheld, radio, a dual bander, and it was very difficult. But I was very successful hearing quite a few of them. And it was fun building a homemade antenna. It didn't cost much, it was just, the exercise. But if you comment about the different modes, and if anybody, I don't know if they're using computers or anything like that, but if you comment about that.
Yes, so I think one of the modes I'd be interested in trying is the FT4, which is, I think people are running that on these linear satellites. So you really do want to be using a computer for that, because of course you have to keep both the send and receive tracking quite accurately with that. So it's basically the same as FT8, but it's just twice as fast. CW again is something I've heard on satellites. A lot of them transmit a CW beacon, but to make CW contacts is also possible. Again, I think you probably want the tuning assistance, because there'd be rather a lot to juggle trying to do a CW contact and direction and Doppler all in one go. There's just the FM voice, of course. I think those are the main modes I'm aware of.
Paul, do you have a question?
Yes, I do. So you mentioned calibrating the magnetometer and forgot the name of the other one.
The accelerometer.
And when you lose power, does it all go away?
No, so that calibration is actually stored on the Arduino. So you only need to do it once, and it's good. Yeah, and it's a good job too, because that's quite a process. It took a fair while to get that set up. So thankfully that's, I think if you were to move to a significantly different area of the country, maybe where that magnetic dip and declination differed, you probably would want to do it again. But if you're just in a local area, I think you're probably fine.
Then the position of the arm with the sensor has to be accurate when you assemble.
Yes, that's true. I mean, I could rotate this differently from the antenna, and then you'd be a bit in trouble. You definitely do have to keep everything assembled fairly standard. I need to 3D print a holder for this to hold it in place. I mean, part of this electrical tape is actually an adjustment device that allows you to fine tune it, but I think something more sophisticated at some point would be better.
Usually duct tape, though.
Duct tape, okay, yeah, okay.
Any other in-room questions? Any more on Zoom? Yep, we got another one on Zoom.
Let's see, this is a question from Greg, and Greg, if I get this wrong, you can unmute yourself, but what I'm reading is, which are the best FM voice satellites?
I would say, so there's these Tevel satellites that have literally just been launched at the beginning of this year. Absolutely brilliant. I went outside just with an HT, and I was listening to people talk. I think it was Florida or somewhere like that, as if they were literally in the next room, full quieting. So I highly recommend those. They're being switched on and off quite regularly, so do check with that AMSAT. The International Space Station is also very good. Those are the two I would definitely start with for FM contacts.
Okay, I think that, Ben, thank you very much.
Okay.
Really appreciate it.
Thank you for your opportunity.
This year for field day, we'll probably have four folks signed up for HF operation and 112 for satellite. So if we get QSA, if we get a Q problem, we know where to go.
Great.
Thank you very much.
Thank you.
Okay, if we could swing back to the presentation. Green light works better. Okay, let's move to officers' reports. And let me start circular around the room. Lori, do you have anything that you'd like to bring up as a secretary? Other Christmas, any additional notes, comments? Okay, so again, Christmas party sign up time. Lori will send out another email shortly on the group's IO reflector. Probably be pretty much a carbon copy of the one that she sent out before. Please respond so we can get a good count. If you have not yet signed up tonight and you are able to, please do. Let us know, and then we will be able to move forward. So thank you. And let me go over to Dan. You want to go up front or you want it here?
I'll say here.
Okay.
Just the usual, if any of you are here and want to check your due status, I've got the book here with the paper copies, but they do go out before each club meeting to a group's IO with a URL link. You can check it, and I presume most of you have. And also the personalized email you get about the meeting contains your due status. Would like to recognize two people this month. First of all, with the work Wilson did back in August, that was quite a donation to the club for the equipment that he took care of disposing. That was $400. And when Steve Album cleared out his place, that was another close to $600. So those kind of donations as a club really do make a difference in a club treasurer. And I want to thank Wilson is here. Steve left on his journey out west October 4th. And I guess we won't be seeing him in person again.
But he will indeed be missed. If you ever went to a field day, Steve was in the middle of everything. You know, he had his big Hilton travel bus there for some of us to go relax either outside under the canopy or inside in the air conditioning. And he was there from beginning to end, helping build things, take things down, fix things, whatever. Steve was always there. He was our Orange County EC for a period of time, worked with the Orange County Emergency Communications Office, and ran several training classes, antenna building classes when we used to meet over at the EOC building. And he will indeed be missed. But a couple things, his email address won't change and his cell phone number won't change. So we can still bother him on occasion when we need to. So that's great. Wilson.
On that happy note, sorry to lose Steve. For those who are interested, his domicile is going to be just north of Seattle. His significant other has a place there, but he's keeping the observatory in New Mexico, and we'll be spending time there as well. And I don't think anybody knows probably that a friend of Lowell's bought the trailer, and he's an avid DXer, and it will likely be at the Mountain Field Day of Lowell and his brother-in-law this year.
That is great news. I'm glad to hear that that trailer was purchased. We used that many years and it was really great. It's just something that, you know, for a list of reasons, we thought it probably not good to buy it as a club. And I didn't want to have it stored myself. So, okay. Okay. Any board of director comments? D, John. Okay, we think we have a program for November. We're not quite sure yet. Okay, but if we do,
I
it'll
have a
be.
comment.
Aurora. Okay, I didn't know you were on. Yes, go for it.
I'm here, but I'm here on my phone, like via phone, not via. I was driving someplace with driving back home from a place with a lot of dead spots. I just wanted to announce that if the weather is nice, our Ham Pie meeting will be a satellite day. So we'll meet at Gold Park. People can come try out stuff, and if this inspired you to pick up some Yaggies, come bring your Yaggies and HTs, and hopefully the weather will cooperate. That's all.
Yeah, what's the date on that?
It's the third. It's not this side. It's the 21st, I think.
Third Saturday of the month.
Third Saturday of the month.
Yep, we got
I think
some
that's
people.
the 23rd.
Okay, we got folks jumping for their cell phones. Yep, 21st. Okay, October 21st. Excellent. Good suggestion. Any other comments, Aurora, from your board viewpoint? Board of directors viewpoint, not board viewpoint. Let me fix that. Chris, anything? All right, hang on. Go ahead.
No, that's it. Yeah, we're looking for more people, and anyone in the Ham Pie group who's listening, we're looking for a webmaster.
Okay, we got a note posted from Zoom. What time on that Saturday?
1:30.
1:30. Okay, excellent.
1:30 Gold Park, Hillsborough. Weather permitting. If the weather is bad, we'll have our normal virtual meeting.
Okay, Chris. Okay,
And
let me walk over to Chris now that I'm blind.
I just wanted to reiterate what Bruce and Aurora even mentioned about the need for bodies on the board to run the club. And if there's any interest whatsoever in furthering this hobby, let us know. Whatever your interests and passions are, we can put you to use. There's some specific positions that we have and some less specific positions, but like I said, if there's any interest whatsoever in serving with the club, to be part of it, help make decisions, further the hobby, further the interest, just let us know.
Thank you, sir. Very well stated. Okay. Okay, done with officer reports and board reports. Any comments from any of the members? Anything you'd like to talk about? Any questions you have? Things you're working on? Projects you might need help for? Parts you need? Any equipment that you want to buy from Wilson? No, I don't think he wants to buy anymore, but he does still have a cellar full of stuff. And he's got an SB 300 that he's really surprised, or two of them. How many do you have?
SB3, that's the receiver. SB 200.
Oh, the 200, the amplifier. I'm sorry. Yeah. Okay, if anybody's looking for an old amplifier, but solid, not a lot of moving parts, 572Bs or 811s. 572Bs. Okay, 572B tubes, and you get to actually look at them glow, and after they're on for a while, you can actually smell them like you can with the old time radios. It's a reliable Heathkit amplifier. Again, not many parts, easy to fix.
21.
Oh yeah, if you need a kilowatt, an SB 221, 3-500s. Yep, good tubes, 3-500s. Okay. Any comments from anybody on okay. Well, I think that will be a wrap. Thank you all very much for coming tonight. Again, Ben, thank you very much for that presentation. I think we'll have some more interested folks on the satellite stuff. Oh, wait a minute. We got something going on. Hold on. Let me walk over to Lori.
And Ken has an update. Ken, if you want to go ahead and unmute yourself, that'd be fine.
Okay. Last meeting, I mentioned a possible thing to use the back of the church bulletins for expanding our groups as advertising. That would be definitely cost prohibitive. That is not free by any stretch of the imagination. A little tiny 2x2 square on the back of a single church bulletin is about $250 every 6 months. So $500 a year, and that's per parish. So it would be cost prohibitive. So that's definitely out for advertising our groups.
Yeah,
Thank you.
First of all, thank you very much. Thank you very much for suggesting that, and also for going back to find out what the cost would be. Yeah, I think that's a little bit beyond the affordability model for our club. But
I thought so
thank you.
too.
Thank you very much. Okay, if that's the end, go ahead. Thank you everybody for coming. One more page. The next meeting is on November 13th. And we will see you then and talk to you on the 10-meter net and on the 70-centimeter net before that. And maybe some of you will be at the DFMA meeting before our next meeting. Right, Bob? Okay. Thank you all very much.